there was this, it was using an interface, this int iterator interface, and the way it was being used was it was being implemented by this inner class. And notice where it is being defined. This inner class, and if we look at the scope of the inner class, it goes from here to here, and then notice that it is enclosed by the class. That's what makes it an inner class. And just, come on, Zoom. Zoom was misbehaving, and the video, even though it was recording throughout, was not saved. I don't know why. So the only record you have of what we did yesterday is in the code here, and the code is not what you're doing here. I said I didn't, there were several parts of the requirements here that were not finished, specifically the remove methods. However, those were just incidental to what the purpose of this was. Again, the purpose was kind of twofold. Well, the main one of which was to illustrate an inner class. And the reason why an inner class was needed here gets back to the idea of encapsulation. In other words, what was desired here, this iterator concept, which we've seen before when we covered collections, is a way of safely navigating through one of these data structures in a way that doesn't muck it up or muck it up too much. Okay, so we wanted to implement that. Now the thing is that an iterator, for it to do its job, has to be able to access the actual data that's in there. In this case, since we were emulating an array list, the data was contained in an actual array itself. If we were doing something like a linked list, then it would be a little more complicated, because there we would typically have objects that would contain the data, and those objects would point to other objects. That could be another example of an inner class. That is, these objects have no use other than to manage what goes on inside of a linked list. Again, we're not going to explicitly cover that, although I might, since it covers the same kind of concepts as we're dealing with here, it's something I might ask about. But anyway, again, the idea is that this class, this iterator class, needs to have access to this data. And the question is, how can it do it? If it is a separate class entirely, then what's going to have to happen is that this outer class is going to need to expose what these values are. And the problem with that is that if it exposes the raw data to the outside world, and that also gives an opportunity for the outside world to muck with it. So rather than do that, the idea is that these iterators are the only way to kind of really traverse throughout it. I mean, there are methods to add and remove, etc. But again, those are all methods. Those don't allow the outside world to have direct access to the innards. Again, that's what encapsulation is all about. And so something like an inner class, as was done here, is necessary for this iterator to get access to this. And to understand that access, remember the concept of scope. Because the iterator is inside of this class, it has direct access to everything that is outside of it. Now, what doesn't, and so the outside class also has access to the public parts of this inner class, but it does not have direct access to its instance variable. For example, this next index cannot be directly accessed by what's out here. Okay, so it's nested, and it's a one-way type of thing. Okay, so what I'm going to do is I will finish this class. There were two methods again that were not implemented. They didn't have anything to do with the inner class idea, but just for completion, I'm going to implement that and push that so you'll be able to just see the complete thing. The sort of the second side thing, remember we have talked about interfaces, and there was perhaps some question of, okay, why interfaces? And here, the idea is that because this int iterator is a public interface, when the outer class defines this method called iterator, which gives the outside world access to an instance of this iterator, notice that the signature is this interface, not the class itself. And if you kind of think through what's going on with that, because the class itself, because the iterator class itself is defined to be private, that means that no class, no method outside of this class can actually see what an iterator is. It can't import it. It can't declare a method to be this particular class of iterator. And so given that, the only way to expose it to the outside world is through this public interface. And with the interface has just the only two methods that are needed. So the next and has next. Okay, so again, for this example, I will finish the code on this and push it just to complete the class. But again, the message, the lesson for this was I think hopefully gotten on that. Are there any questions about that interclass stuff before we go on? Okay, so all that is perfectly clear. Excellent. Okay, so now we're going to spend some time starting today and continuing at least through next week and perhaps beyond on graphical user interfaces. Up until now, everything has been done via the console. And now we're going to start looking at what Java has to offer when it comes to designing an application that interacts with the user in a graphical way. Okay, so there's a huge framework called Swing. It's the successor to the first try. Just with a little bit of history, I asked you to kind of skim the part in the book that kind of talks a little bit through kind of what was going on. Again, this kind of harkens back to days in the computing worlds that are kind of akin to your parents walking through waist-deep snow uphill both ways to school. Back in those days, before Java came along, it was quite a challenge to write a graphical interface, and it was even more of a challenge to write a program that would run on all the different platforms. At the time, there were a few more platforms that aren't around today anymore. Specifically, Sun Microsystems, that was primarily a hardware company, had these Unix workstations that were pretty much dominating the market at the time. I mean, there were others. HP had some, and there were a number of others. But when it came to small computers, Unix was the king. as opposed to the big iron of IBM and some of the others. And, and then Windows was just in the mid 90s, Windows was just starting to come about. It wasn't until 95 that Windows actually came out with a fairly decent operating system. But they all had different ways of doing things. And so the idea of writing once and running everywhere, that was kind of one of the mantras there, the Java actually was able to fulfill. Now, when it came to graphical interfaces, their first cut at it was something called the AWT, which they termed the Abstract Windowing Toolkit, with the idea that the abstract part was the idea that as a programmer, you could write the same code and it would run on every different machine. Here today, the main three would be Windows, Linux, and Mac. And that's something that we just kind of take for granted these days. That is, if you have an application, it's just assumed for the most part that it'll run on whether you have a Mac or Windows and even Linux. But at the time, it was not that was hardly an assumption that you could make. You basically had to write to a specific platform. And the problem with that is that, if you write a program and your user has to have the right operating system to run that, then it's, you're kind of losing out on a piece of the market. Okay, so this abstract windowing toolkit was actually developed really in very, very short order. What happened was Java began as an internal language because the developers at Sun were not happy with C++, which was kind of the primary object-oriented programming language at the time. And so they came up with this language on the internally. They actually called it Oak. But then but what happened was people started getting word about this this language, and it just kind of blew up. In today's terminology, it went viral, as it were. And so that kind of took them by surprise. So it was really in very, very short order that they came out with Java and released it. And this abstract windowing toolkit was part of that. And it was kind of a crash development. They threw it together, and it actually did succeed in running on all the different platforms. I remember at the time when it came out, to be honest, I was skeptical about this, and I had to be convinced that it would actually do that. So what convinced me was I wrote a program and was able to run it on both a Sun operating system. I was able to run it on Windows. I was able to run it on what else was that? There was a third one. I forget what it was. Anyway, so I didn't believe it, but then when I saw it, I thought, well, okay, there it is. Now the AWT was it was dubbed the awful windowing toolkit because it had a lot of shortcomings. And so after a few years of complaints, Java came out with this thing called Swing, and that's what we're going to deal with. And Swing has some very, very nice features about it. So we're going to start diving into that. It's a very, very rich framework. Pretty much everything that you come to expect in a graphical user interface has some widget that you can use on this. We will only have time to dip our toes into it. We could easily spend the entire quarter on nothing but plowing the depths of all the different possibilities for a user interface. In actuality, we only have a couple of weeks. So we're going to do what we can. As the judge told the 85-year-old man convicted for murder, who sentenced him for 50 years in prison. And the man said, well, hey, Judge, I'm 85 years old. I can't do 50 years in prison. And the judge told him, well, do what you can. So we're going to do what we can. And we're going to begin with the different components. The chapter in the book on this, I have a lot of angst about. Again, I asked you to kind of take a look at it. There are things that the author does here that are actually not very good practice. Almost right off the bat, they do something with the Jframe, which is kind of a no-no. They do things with the action listeners, which involve anonymous inner classes, which is another no-no. And so what I will present you with is what I think is the alternative to that. So the components that we will start with today, hopefully, Jframe. That's the Jframe is basically the window of the application, and we'll start with that. And to understand how a Jframe basically lays stuff out, we need to deal with these things called layout managers. The main one that the Jframe uses is something called a border layout. There are a ton of these layout things. They describe how the different widgets in the interface get laid out, basically. And then we'll sort of take a look at basically kind of three of the primary things. A JPanel is basically a panel in which you put stuff. So remember, yesterday we talked about how inner classes are like Russian nested dolls. When it comes to dealing with Swing, the analogy is even more apropos. In other words, what you do is you have these things, and the outermost one is going to be a Jframe, and then you will typically have these sets of nesting things. So inside the frame, you will put a series of panels, and inside these panels, you'll put a bunch of widgets. And by widgets, I mean these things like the J label, which is just some text, and a J button, which is something that you click. And then, as we'll see, just putting them up doesn't do anything, and we need to make them live. And so the first sort of live thing that we'll look at is a button. You all know what a button is. Use something that you click on. It's one of the things that's changed over years is that when this was first coming out and we were starting to sort of teach this, a lot of times students in your place would not have nearly the experience in working on a personal computer as you all now know. I mean, it's reasonable now to expect that you all know how to run an application, and you know kind of what to expect, and clicking buttons and interacting with these things. You have a lot of experience with it. So even if you haven't explicitly, formally sort of talked about that, you all intuitively know what's going on in that. And you also intuitively know what to expect in an application. And as hopefully you'll learn by our brief tour of the sausage factory, all of these things are things that the programmer pretty much has to put in. In other words, they don't just happen. And we'll sort of talk about that as the time comes. Okay, so I want to just in general be spending a little less time yapping at you and a little more time just showing you some code. All right, so and actually, wait, I think for this, I need to share the entire screen because there are going to be things popping up. And all right. And Zoom keeps putting stuff in front of me. All right. All right. So the first thing is a Jframe. Let's put this into a package called Swing, because that's what we're going to deal with. Okay, so let's define a class. Again, everything that we've been talking about since day one is applicable here. So we're defining a class, and the way to specify the outermost window is to extend a class called Jframe. Most of the swing components have a J in front of them. That doesn't mean that it's a joint operation. It means why the J? Well, when it first came out, actually swing, they weren't entirely sure if people would accept it. It first came out as kind of as kind of a exploratory, or how should I say, an extension. And so that's why its base package is Java X. So it was considered at first to be an extension. It since has been part of the mainstream Java, and most graphical interfaces in Java are written using Swing. There are some alternatives, and there are third-party alternatives even. But because it was part of the extension, they decided to make it Java X Swing. And what happened was, and this is kind of a cautionary tale on these things, it was very popular, and there was so much code written using Java X Swing, is that when they tried to make it just Java Swing, it broke everything. So they decided to just keep it with Java X Swing. But nevertheless, despite the X, it's a key element of Java, and has been for some time. Okay, so basic inheritance. Jframe does many of the standard tasks that are associated with having a graphical interface. And like any class, if we don't give it a constructor, it will give us one. But one thing, remember, our first call is to super. And if we look at what the super is, we see that the Jframe constructor is heavily overloaded. It has an empty constructor, which we could have guessed since we did not get a red squiggly when we didn't write one. And we see there's one called a graphics configuration. And that has to do with the locale type of stuff. If we had some international students here, then we'd sort of talk about that a little bit more. But basically, this is basically sort of a hello world type of thing. So the super class, the super constructor, just gives a title to this. Now, some of the other things, well, let's just to kind of see what goes on here. Let's we can actually run this and see what happens. What I'm debating about is, okay, I'm gonna put my main classes in a separate place. Now, running these requires just a little bit of dancing around. So okay, so again, everything, red squiggly cannot find symbol. What do you do when that happens? We try to fix the imports, and then if they get fixed, then fine. You know, here's where we have to touch on that threading thing. In a Java graphical application, there is a single thread called the graphics thread that handles the graphics, that draws the graphics. And in order to make sure that your program is going to be is not going to lock up too much, we need to make sure that this Jframe is put on that graphics thread. And there's sort of a special dance that we do for that. And that is, now the book, when it first came out, what they realized is that just kind of putting it out there would not guarantee that the frame would be on the graphics thread. For something really simple like we're doing, that's actually not an issue. For a more complex application, it is an issue, and it can lock up your application, which you definitely don't want. In order to avoid that, And to put this on the graphics thread, we need a special call. Now, there are actually a couple ways of doing that. What happened was that they wrote something called swing utilities. And then they realized that that was kind of a Band-Aid, and then you can still use that, but there's actually a static method, a class called the event queue, which is what we're going to use here. And what the event queue has several static methods, and the one that we want is to invoke later. Now, invoke later says, it basically says, okay, see, here's what's going on. There's a main thread that that runs here. In other words, one thread that the Java virtual machine creates starts executing the main method. But that's not the graphics thread. The graphics thread is something else. So what invoke later requires, if we look at it requires a runnable. So this is one place where the one exception to an anonymous inner class is valuable. And actually we'll first violate that, and then we'll actually replace it with something called the Lambda, which we're not going to cover in depth. But anyway, so what we can do is an anonymous inner class is one where you can do this. Okay, so now notice the syntax. I said new, runnable is an interface, and then I did an open curly as if an open close curly as if I were defining it as a class. So within this one method call, I can actually define a whole class and instantiate it in one fell swoop. That's an anonymous inner class. It's anonymous because it doesn't, I don't give it a name. And again, this is the one and only place where that is going to be acceptable. All right, so now a runnable requires a run method. And so we can implement the abstract methods. Okay, it's not going to do that for me, so I'll just have to implement it myself. Okay, what are you doing to me? Okay, so all right, so what's happening here? Again, this is something this is the one and only place where this is going to be allowed. And that is because invoke later requires a runnable as its argument. We could define a whole class and implement runnable and pass it to that. In many ways, that would sort of be strictly speaking, that would be kind of a preferable way to do it. But that's kind of heavyweight, because all we're doing here is to put this on the event queue. We just say we set it visible. Okay, well, what are you saying? This creation. Okay, we're going to turn it into what's called a Lambda expression. We're not going to go deeply into what these Lambda things are. This is going to be the one and only place that we use it. So this is one way of doing it. As you can see, it's sort of a lot of typing, but we can now actually run the program. And okay, so now what happened? Where did it go? Oh, look at this. There's a little thing up here. There it is. That's our application right here. Isn't that exciting? Well, it's awfully tiny. All right, what happened? Well, what happened is that the default size of this frame that we created is 0 because we haven't told it anything. All that stuff is actually there. In fact, what we can do, look, we can make it bigger. And there's our hello swing that we had as the title. So all that is there. And okay, so now if this were Windows, the little red X would be on the right, and Apple, just to make it different than Windows, or Windows to make it different Apple, they may put it on the left. Okay, and I close that. Now something, okay, a couple things is what to do about the tiny little thing that was just put in the northwest corner. And then a second thing, though, is something that we need to notice here. Look at the console, and then look at this. The program is still running. So we close the window. The program is still running. Okay, we can stop it by clicking this little red box here. But what happened? Well, what happened was that we didn't tell it any differently. So how can we fix that? Well, what do you do when you close a window? Does it shut down the application altogether, or does it just close that window? It depends on the application. So by default, when we close the window, the program keeps running. If we want to change that, we do something called, we set the default close operation, and one is called exit on close. There are actually a number of these different ones. So there's exit on close, there's dispose on close, do nothing on close. So we're going to begin with exit on close. So that's going to do something which is useful for our examples and going to be kind of a bad thing later on. In other words, imagine you're imagine you're writing a long Word document, and then at some point you accidentally or deliberately close the window and hit the red X. What should Word do? What does Word do? It does the right thing. It says, hey, you have unsaved changes. Do you want to save them? Yeah, that doesn't happen just by itself. That happens because some programmer put that in. When we say exit on close, it's just going to shut everything down. Now, what we can do is we can actually set the size. So I'm going to set the size to the units or pixels. So I'm going to set the size of this window to 400 and 300 pixels. Again, this is sort of violating one of our dictums about hard coding values in, but it's not, again, for demonstration purposes. Okay, so now, as you can see, it's made a bit bigger now. So here's our frame. And now when we hit this, notice that the program now closes because we said that we told it to. Okay, just before we continue too much more, notice that it's suggesting that we turn this into something called a Lambda expression. And I'm going to do that because that is a little bit more, a little less typing. Okay, so, and again, we're not responsible, I'm not making you responsible for what these Lambda expressions are, because that's a whole topic in itself. We could spend a lot of time just delving into what that's about. It's an approach which actually it runs a bit counter to object-oriented design, which we talk about. It was something that people really wanted Java to have. They put it in a few versions ago. Some people really love it. To be honest, I find it not terribly useful, except in situations like this where it just, the syntax is a little bit strange, but it just makes it a little clear what's going on. What's going on is all we're doing is setting the frame visible. Okay. Now let's start putting stuff in. So the first thing I'm going to put in is a button. Okay, and again, red squiggly says cannot find symbol, so we fix the imports. Okay, one kind of useful pattern is to have a separate method to sort of initialize the layout here. Okay, so let's see what's involved with this. Well, first, what we're going to do, well, I'll tell you what, let's, first I'll do it. So let's, okay, so a J button, now it has a lot of different options here. Again, I can just create an empty one, which won't have any text in it. I can create one that has a text. I can give it an icon, which is just going to be a little picture. I can give it text and an icon. That's, we're not going to get that fancy. So all this says is I'm going to create a J button, and this is going to be the text on it. And then now here's where I think I disagree with what the book at least initially does, is that everything that we put into all the widgets that we put in, we don't put it directly into the frame, we put it into something called the Content Pane. Okay, the Content Pane. And then the Content Pane has something called an add. And it can add, and again, thanks to the way that the inheritance hierarchy is set, because this add is, if we look at the signature, there are a number of them, but notice this thing called component. So component is a class which is way up on the hierarchy. All of the widgets extend at some point component. And so what that means is that any place I can add a component, I can add one of these guys. Okay, so let me tell you, let me just to be able to, let's see. All right, so now when we run it, okay, what happened? What happened is I didn't call init. There we go. Okay, so now what happened when I added it? See, this is the button. Notice that when I click it, it kind of flashes, which shows that it's actually been activated. What happened was the Content Pane has one of these things called a border layout. And looking at the time, we're going to have to talk about the border layout next time. But instead of just adding it there, if I add it to the north, and if I fix that import, I notice that north is actually a static variable of a class called border layout. So now when I run it and I put it in the north, we can kind of see what the north is. The north actually extends all the way across at the very top. You can say, well, I could also, what about the south? Is if there's a north, there must be a south. So where's the south? Well, the south is where you would expect it. Well, what about other directions? There's an east. If I put it in the east, it goes here. And again, this is, it knows that the button is kind of doing, the button is there. It's responding to my clicks. And okay, so, and if there's an east, there's going to be a west. And where it was originally was a place called the center. Okay. Now the thing is, we go back to the north, which is where I wanted to put it in the first place. We see that the button just kind of covers the whole thing, and that's generally not what we expect. We expect to see a button that's a little bit smaller than that, and that's where the nested dolls kind of come in. So instead of putting it directly in here, we're going to put it into a panel. And I can just make that a local variable because I'm going to kind of stuff it in. I could make it an instance variable. But for this example, I don't need to. Now, each of these containers has a default layout. So what I'm going to do is, instead of putting the button into the panel, I'm going to put into the top. I'm going to put the panel into the top. And then what I can do is I can add the button. Okay, and what that produces is something that looks a little bit more like what we would expect. Okay, so instead of having the button go all the way around here, the button just has its natural size, its regular size. And again, notice I'm clicking it and it's not doing anything. Okay, so how can I make this do something? Well, what is it that I want to do? Tell you what, let me, what I want to do is do something like just sort of count the number of clicks, okay? And then what I'm going to do is put a J label there. Oops, yes. Label. And then I'll add that. Now, what's a J label? A J label, it's kind of like a button, but okay, what I'm going to do is I'm going to add it to the south. And while I'm at it, I'm going to kind of move this over a little bit. So I don't have to keep dragging it. Okay, so we see here, this is still going on, and then here's our J label down south. Okay, so that's just going to record the number of clicks that we have. All right, so now how can I make this button do something? And this is where our our named inner classes come in. What the book, and unfortunately a number of different textbooks and even tutorials seem to advocate, is putting what the button does into an anonymous inner class. And that is really terrible design. Instead, what we're going to do is we're going to use a named inner class. So I'm going to call it a, let's say, okay, there's an interface called Actionlistener, and I'm going to implement that. Okay. So an action listener is one of the interfaces, and an instance of that, if it is listening to something like a button, will respond to its clicks by the action performed method. Just as we discussed with the named inner classes here, because this has access to all of the instance variables, when the button gets clicked, the action performed event is going to be invoked. And what it's going to do is say the number of clicks. I'm going to increment the number of clicks, and I'm going to update my status label by pretty much the same thing. Okay, so every time that I click the button, this is going to get executed. But it's not going to happen yet. Why? Well, I'll show you. Nothing's going to happen now. Why? Because I haven't told it to. I need to tell it, oh, by the way, when this button, when you get clicked, here's what I want you to do. And here's how I tell it. It's called my button, my add action listener. And actually what I want to do is I'll instantiate one. So okay, what have I done here? First, I've instantiated one of these inner classes. And I can only do that inside this class because this is made private. And then by saying add action listener, I'm saying take that instance, and whenever you click, this is going to get invoked. And now when I click the button, we see down here that every time I click it, it updates this. And in fact, we can test that by running it as a debugger in the debugger. So we see this comes up, and so when I click it, it will come down here and executes that. And then if I just step through, that's okay. Again, it hasn't done anything yet, although it has updated the number of clicks. And then when I do it again, now, oops, I think I need to come out. Oops. Yeah, there it is. So even, come on, running in debug. So every time I click it, then something happens. So that's how we make one of these widgets live. That's the primary, and there are actually a number of different ways. There are listening to the mice clicks, and you can listen to what the mouse actually does. Those are a different set of listeners. What I have found is that this action listener is, in my view, the most effective way to make these widgets live, because almost every widget that does something, whether it's one of these, whether it's things like combo boxes, lists, check boxes, other things, they all will respond to an action listener will respond to all of those, as well as some other things. Okay, so just to review, we've seen how to define our window, which is an extension of a Jframe. We've seen a couple of widgets. We've seen the button, we've seen the label, we've seen how we put them into a JPanel, and we've seen and then the other thing is that when running it, we use this event queue, invoke later, and then have just this one strange way of writing this line of code, which is just what we're going to be doing when we run this for now. Okay, so we're going to continue delving into building a graphical user application in Java, and that will commence next week. Tomorrow, again, as usual, a quiz at 8 o'clock and some more fun that I have for you. So if there are no more questions, I will see you then.
So did you say you're gonna put the code up tonight that we're gonna work on tomorrow, or the assignment?
Yes, I'll try to put that up this afternoon.
Okay, thank you.